Let's go to the one with the obstetrician. So she wanted to know whether the proportion of children born on each day of the week is the same. She randomly selects 500 birth records and obtains the data in the table. Is there reason to believe that the day on which a child is born does not occur with equal frequency at the alpha equals 0.01 level of significance? Now, me just looking at the table, which I did, is I said it looks like there's less births on weekends. So that's really what she's looking for, is it really different than every single day of the week? So the first thing you do is prepare your data summary, your observed and your expected in StatCrunch. Now my observed, I just typed in the numbers from the chart before. For my expected, I said, well, I'm just going to put the same number for every single one, because what we're looking for is that the percent per day is the same. If you look in the book, they're going to take this total, which was 400, and for each of these, it's going to put 400 over 7. So take that 400 births and put them equally into the categories. Because we're using StatCrunch, we don't have to do that. It does it for us. Is it 400 or 500? I don't remember.
I think it's 500.
500? Okay. 500. So we'll just change it to 500. So we would expect each of those to be 71.3, I think it is. Okay, and we'd expect them to all be the same. But again, because we're using StatCrunch, just put the same number in each, and it'll take care of it for you. So that's what I put in. I did stat, goodness of fit, chi-square, and I got a p-value here. I'm going to zoom in on this a little. It looks really small. So I got a p-value of 0.003, which is really small, and a chi-square of 19.56. So we do have a small p-value. Is less than alpha, so we reject the null hypothesis. And so we do have enough evidence to say that the number of births is different on different days. So the proportion of births is not the same on each day of the week, because we can reject the null. Now, StatCrunch gave me this warning here, and it'll happen to you, so I wanted to talk to you about it. Because we didn't figure out the percent per day, we didn't figure it out, like what 7 days would be the proportions, or the counts, where we did 500 divided by 7 and put that on every line. It just gives you a little bit of warning, but it figures it out for you. So here is the actual 500 divided by 7, 71.428571. So it does it for you. And I love when it does it for me. So that's it. Any questions?
I'm just kind of confused as to why you put the 1 in.
Because I was lazy. It's true.
That works, okay.
So I'm going to go back to it and show it to you. Let me go back and clear it. So here's the observed values. Those were the days of the week, Sunday, Monday, Tuesday, all the way down. And I just wanted to say that these are the same. So I just made them all 1 so that they'd be the same. And I said, well, I just played with it and said, what'll StatCrunch do? And what StatCrunch does is it figured it out for me. So I didn't have to do anything. Now, if it gave me an error message, I would have done something different. But it doesn't give you an error message. It gives you a warning. I'm good with a warning. And it figures it out for you that it would be 71.42 in each if they were even.
So is the reason why you put the 1 in the expected is because they, like how with the M&M's one, they gave us like what it's supposed to be?
Right. They gave us percents. What
Okay.
you could put for a percent for each. Let me go back. So the expected can be either a percent or it can be a frequency. And it'll work either way. In the chi-square formula, it has to be a frequency, but not for a stack crunch. So a percent or a frequency. So if it was going to be the same frequency every day, I would take the 500 and divide it by 7 and put the same number in each one if I had to put a frequency in,
Okay.
right?
Mhm.
If I wanted to put a percent in instead, I would just let me break these 7 days up and do 1/7 for each. Because that would be the probability of each of them. If they were exactly the same, would be 1/7.
Mm.
Right? It's like having 7 things seven numbers in a bag, and you have to pull one out to see what's the probability of that one coming out. Be 1 out of 7. Okay. But StackCrunch does it for me, so I don't even have to think that hard. I'm all for not thinking hard. All right.